to continue on with our 9.3 notes, I'm on B. Theta equals negative 130 degrees. And what I want to really do with this negative, or at least there's options. What I like to do is I would like to take the coterminal to it. So if I take negative 130 degrees plus 360 degrees, that gives me 230 degrees. And now I really know the positive. And that helps me a lot, because I know it's from here to the center all the way over past 180, right around here for 230 degrees. So, to me, that helps a lot. So I like to do it like that. There's my 230 degrees. Again, it would be the same thing as, let me use a different marker, this negative 130 degrees if I go from here. No matter what, I'm in quadrant 3. Okay? So that's the important part. Quad 3. Okay, now in quadrant 3, I go right here, degrees. Your reference angle is your theta minus 180. And I'm obviously going to use this one right here. Okay, so that's another reason why I want the positive. It always works with this. Not that I 100% need it, but 230 minus 180 equals 50 degrees. Now where is that 50 again? Well, the key is the 50 is always in reference to my x-axis, and in this case, it's this right here. So my reference angle is 50 degrees. Okay, so now that is everything with this problem. I'm going to rewrite that one more time just so you see it, but reference angle equals that. Reference angle is 50 degrees. There is our answer. Alright, I know that was a lot of work to show just that. But that's how we go about it. Okay? Alright, what you're going to do is flip over to page 11. You're going to try number 6. I'm going to show you the answer. So please pause now and give it a go. Okay, 6a, your reference angle is 40 degrees, and then 6b, your reference angle is pi over 4. Take some time to look through that. I am actually going to keep on going, so pause if you need. Alright, here we go. Core concept, evaluating trig functions. Alright, so step 1 is finding the reference angle, which we just did. Alright, step 2, evaluate the trig function for theta. And then step 3 is to determine the sign of the trig function value from the quadrant where it lies. Okay, and this is a big part, and that's what this is in reference to right here. Okay, here are our trig functions, and you should look over this, but here is a shortcut. For only positive values, all positive values only, you could use this. So this is all. Okay, so sine, cosine, tangent, cosecant, secant, cotangent. This would be sine in cosecant, tangent in cotangent, cosine and secant. I use, all students take calculus. Alright, and I usually write this on the top of my page in reference. So again, you can see if you look here, sine and cosecant in quadrant 2 are the only ones that are positive. If I look in quadrant 4, sine and cosecant are negative, cosine and secant are positive, that's where that c comes in, and then tangent and cotangent are negative. So this only works with the positive values. Alright, scoot on down. Here we go. Using reference angles to evaluate functions. Number 7. evaluate tangent of negative 240 degrees for A, and B, cosecant of 17 pi over 6. Alright, so here we go. A, negative, right? I am going to go ahead and take that, and I'm going to say negative 240 plus 360. My coterminal gives me 120 degrees. Now I have the positive. Which quadrant is this in? Quadrant 2. Alright, so now I can refer back to quadrant 2 right here, 180 degrees minus beta. So now my reference angle is 180 degrees minus 120 degrees, which is 60 degrees. Okay, perfect. Next, what I'm going to do is determine the sine. Well, it's from this tangent right here. So, tangent is what in quadrant 2? Well, if I look at quadrant 2, I see my S, which means those are only positives, so tangent would be negative in quadrant 2. Alright, so now I'm going to use all that. So here I have tangent of negative 240 degrees. Okay, should have been on the inside. Equals. Alright, so since it's negative, it's the opposite of tangent of my reference angle, 60 degrees. And that is equal to what? Well, it's equal to the opposite. And what's the tangent of 60 degrees? Well, 60, 30, 60, 90 is a perfect right triangle, or a special right triangle, I should say. And then if I refer back to page 1, tangent 60 degrees, I get root 3. And that's the answer I'm looking for right there. Okay. B. Okay, so now I have 17 pi over 6. And this is way over 2 pi, right? It goes way past the 360. So I am going to subtract 2 pi, which is 12 pi over 6 if I have common denominators, leaving me with 5 pi over 6. Okay, so 5 pi over 6 is almost 1 pi, which means that would be almost 180 degrees. So I know that is quadrant 2. Okay, if you don't know that though, you can always refer again here. Where is 5, 6 pi? Right there in quadrant number 2. Okay, that's on page 7. Next, I want to find my reference angle. Reference angle in quadrant number 2 is pi minus beta. Okay, so I have pi minus 5 pi over 6. Okay, so I'm going to make common denominators. I'm going to make it 6 pi over 6 minus 5 pi over 6. Now I have common denominators. I can combine, and I get just pi over 6. Okay, so my reference angle is pi over 6. Okay, great. Next thing I'm going to do is refer to my sine. The sine I have right here is this cosecant. Alright, and I'm looking in quadrant 2. And what's cosecant in quadrant 2? Well, it's positive, right? It's positive in quadrant number 2. So now I go ahead and solve. So I have this cosecant 17 pi over 6 is equal to the cosecant, positive cosecant, of pi over 6. And that is equal to what? Alright, well this is a little tricky. So I am going to refer to that circle, unit circle here that we have. And I'm going to look for pi over 6, and it's right there. And I know it's hard to see, but There it is, and that is 30 degrees. And again, that's a special right triangle, 30 degrees, right? So, what I'm going to do is refer back to page 1. And what is cosecant of 30 degrees? 2. So my answer is 2. Alright, and there are the answers I'm looking for right there. Alright. Please go ahead and flip and try number 8. I'm going to go ahead and do it right now. So pause the video, give it a try, and then check your answers. Okay, here are the answers to number 8. And what I'm going to do is I'm actually pause now and continue to look at that. If you need, I'm going to scoot it up just a little bit and also show the real life problem. And because of time, I'm not going to read it all out, but basically here was my equation, and I had a velocity, the speed of 105, and I had a degree here, which is my theta. So I just plugged in those two things and simplified it out, and I get 339 feet. But in golf, we mostly talk about yards, so I just went ahead and converted feet to yards, and I got about 113 yards. Okay? Feel free to pause and take an extra look at that. And that is it for our lesson, you guys.